Good morning, everybody, and welcome to the second session of our November sprint. And on behalf of the organizing committee, I'd like to welcome you. We are going to be focusing on a new tool that's being developed to model disaster risk immediately after an earthquake. I am, with great gratitude, acknowledging that I'm coming to you today from the fantastic landscape of Squamish on the ancestral territories of the Coast Salish people and the Squamish Nation. And it's a landscape that's a very powerful landscape that reminds me constantly of the need to be vigilant and also the teachings about living on an active landscape that have been passed down through the generations, I think are very relevant to what we're trying to do here with understanding risk. Our symposia would not be possible without the support of our partners. And so we'd like to take this opportunity to thank Natural Resources Canada, the Canadian Safety and Security Program, for their funding, as well as IBC, the Office of Housing and Construction Standards, BGC, EERI, the BC Real Estate Association, and Engineers and Geoscientists BC. So without their support, we wouldn't be able to bring these sessions to you. But I also want to take this opportunity to thank you for your support of our symposium over the last couple of months. And without you, we wouldn't be hosting this session. We wouldn't be getting such rich feedback. So we wanted to take this opportunity to thank you as well. A quick note: we've kind of been hitting this theme pretty hard, but for those that may be joining us for the first time, I just wanted to take the opportunity to situate the work we're doing in the broader context of work we're doing here in Canada, but I think particularly here focused in BC, really asking this question of how do we go about implementing Sendai on the ground. And this symposium is a way to kind of check in on activities that are happening here in the region and where they fit in the spectrum of implementing Sendai. And in a very simple way, we can think about it as comprising three steps. The first, understanding the risk. The second step is taking that knowledge to help think about choices and the consequences for reducing risk. So different strategies. And then the third component is taking those insights into risk governance and trying to operationalize or put those actions in place on the ground. And all of our sessions speak to one or several of these themes. And so this is a way that we kind of keep focused on what contributions people are bringing forward and where they fit in this bigger picture. So on that note, today, we're going to be focusing on some new approaches to thinking about earthquake hazards and risk in those moments just after the event. Our session today is convened by Tiegan Hobbs with an amazing group of collaborators. And I wanted to just take this opportunity to note there was an unfortunate error in the attribution for today's session. So I just wanted to emphasize, who's putting this on and who the contributors are. And Tiegan will introduce them here shortly. And before I hand over to Tiegan, I wanted to just take this opportunity to acknowledge the contributions of our colleague, Stephen Bibby, who passed away this past summer from cancer. Many of you will have known Stephen. We worked with him in the early part of the programming for this symposium. We were so saddened to hear of his passing, but we wanted to dedicate our session today to the amazing work that Stephen did and with his quiet leadership. He made such huge contributions to our work in this field and post-disaster building assessment. His work is known internationally, very highly regarded internationally, and certainly he was a leader for us here in British Columbia. So we are so grateful for his leadership and his legacy. Tiegan is a research scientist at Natural Resources Canada, seismologist by training, but also a risk communicator by practice. So keenly interested in how to take our understanding of earthquake hazards and risk into a variety of different conversations. And I think you'll see that the work she's bringing forward today is exemplar of how to take fundamental science and transform it into key insights that are needed to inform decision-making. And with that, I'll pass it over to Tiegan.
Thank you, Murray, for thanks for welcoming us here. And I'd like to pass along also a big thank you to everyone joining us today. A big thank you to the URBC organizers, Susanna, Murray, Daryl, who put together this this time for us to share. I'll introduce my conspirators in a minute, but first we're going to have a little video to kind of get us into the mind space of the workshop we're going to be partaking in today. So sort of a chilling way to start our time together, but I think we have a unique opportunity here today to think about what do we do in those difficult moments following a major earthquake, sort of that initial several hours where there's a great deal of chaos, where we're having to, if we have a response role, respond at the same time that we're living through an event. And a lot of our tabletop exercises that get conducted in this region kind of focus on a later time window when we will have a great situational awareness in terms of knowing who and what have been impacted and to what extent. But today we really want to focus on that time at the very beginning while we're trying to collect some information, while the dust is literally still settling. So we invite you to kind of put yourself in that framework. And we'll start by just doing a little quick poll to kind of see who's in the room to get us thinking. So I'll invite you guys to either on a separate window, or if you'd like to pull up your phone, you can go to menti.com and enter in the code that's shown up there at the top. I'll read it out in a second, and that'll take you to the poll that you can fill out. So again, that's menti, menti.com. This first question is asking us to think about where will we physically go after the earthquake happens. So we can see that, thank you to everyone who's answering the poll. We can see that, a clear first place is going home to check on our household members, generally helping out our neighbors and helping our loved ones seems to be the kind of second and third. And then from there we head maybe to start thinking about work. So, of course that makes sense. We need to take care of our loved ones. And aside from the sentimental and human response that we need to take care of our loved ones, just from a practical response, we need to know that our loved ones are safe before we can conduct work. So there's this period of time where, we're all going to be kind of moving around to check on the people we care about before we can attend to the greater community. So now I'll go to the next question. So what is your role in earthquake response, to kind of see who we have here in the room? Lots of people with no role. I have no role, so that's me. We've got some other people who will be working on emergency management, a first responder, people interested in housing, an engineering and science role. And then we've got some federal government and some others. If you're an other, I'd invite you, please by all means, in the chat, you can let us know what your role is, just to kind of help us all start thinking about who, if this is kind of a new concept, it's nice to think, or it's interesting to start thinking about what are the roles that will happen right after the earthquake. So then also, what kinds of information do you use for situational awareness? So we've got remote sensing data, emails and calls, media, news, pager and shake map. So those are USGS released information about the earthquake. We've got school, nothing, local news, radio communication. So I don't know if that, could be radio media, could also be high frequency radio transmission or ham radio. What else? We've got pager. I'm assuming that's maybe like a physical pager, or also the USGS thing. Eyes and ears. Yeah, I think that's, I think in this early period of time, especially, we're going to have to rely quite a bit on our eyes and ears. So we'll keep going. What information will your organization have on hand in the first 1 to 2 hours? So we can see that we've got reconnaissance by foot, some reconnaissance by vehicle, inspector reports, and first responder reports. So really it's a quite physically demanding work to get this information at the beginning, some monitoring instruments. So that might be things like having a seismometer in a building or on a bridge that will actually record the shaking at that piece of infrastructure, and then report back out whether it met or exceeded certain thresholds that are meant to coincide with what level of damage would be sustained. We got 911 calls. So then if we go ahead to the next question, it's looking at 3 to 6 hours. So we've got, a little bit more of this 911 calls. We've got more people putting in that they would have information about reconnaissance, or from reconnaissance rather, by foot and vehicle. We'll keep going forward here. So this one is looking at 6 to 12 hours. And I believe this is the last question. So we can see that now we're starting to get, maybe people are thinking we'll have some kind of aerial reconnaissance by drone or plane or helicopter. So those are the kinds of things that take a longer period of time, because you at the very least need a drone operator who has to have a certain level of licensing here in Canada, and you would need, likely to get information about these critical urban regions, you need clearance from the right agencies to make sure that the airspace is available. So from and I invite this to become a conversation, please feel free to use the chat. But it's very interesting to go to some of these tabletop exercises to kind of hear about that early period of, it's quite a lot of coordination to start getting these aerial reconnaissance tools. The military would likely be conducting aerial reconnaissance, but the estimates I've heard are that it would be somewhere between 12 to 48 hours for the military to be deployed for that tasking. So there, certainly in the first 12 hours, we anticipate that this is the period of time where we know from reports from other earthquakes that it's the time when neighbors are helping each other to try to get out of buildings that are collapsed or partially collapsed, or, they're treating each other's injuries. So it's a time where every piece of information can help us to direct our resources a little bit more quickly and maybe to have a greater impact. So I'll thank you guys for participating. What we want to do with our methodology that we'll present here to you today is to use existing capabilities to assess the impacts of earthquakes within tens of minutes following their occurrence. So we're not, we sort of have taken a look around and said, we think we actually have some tools that might help with this early period of time. And I think we've kind of, all walked through together the motivation of why we might like to have that. We know that after an earthquake, it can take hours or days to understand the extent of the damage. You might have all noticed this before when an earthquake happens and, maybe we go to news or to Twitter or other social media to learn about the impact of these earthquakes, such as the magnitude 7 earthquake in the Aegean last week. And you may have noticed that it takes some time for the results to start coming out. The places that have been most strongly impacted, again, may have disruptions to their communication, so they're not able to send information out of the disaster zone. I believe the island of Samos from the earthquake last week, this week, time's blending together. It took time for people to even reach anyone on that island. So we know that it takes time to figure out who's been impacted. That's also why a lot of the numbers will change in that first week when we're hearing about the earthquake. So it's hard to know what has happened, but we also know that it's kind of the most critical time where if we have collapsed or partially collapsed buildings, that we need to get to those people quickly, both because they may have injuries that need to be seen to rapidly to save their lives, and also because we know that the aftershocks will continue and they'll happen most frequently at the beginning, which means that these buildings, which may have partially collapsed or been severely damaged, are likely to experience further shaking when they're already weakened. So it's a really time-sensitive issue. And so we're very interested in how can we use something to know more. So what do we have currently to work with if we wanted to help solve this problem of early situational awareness? So we know that we do have rapid information about shaking after an earthquake happens from our seismic networks, from our collaborators to the south at the USGS. People already said in that poll that they can go and look at Pager and ShakeMap and using Canadian resources as well. So we know after an earthquake happens, within about 10 minutes, we know how big that earthquake was and approximately how much shaking has happened. And we also have information about the building stock and its vulnerability to shaking. So at Natural Resources Canada and the Geological Survey, we have databases of some engineering information about buildings that correspond to what we actually have here in Canada and how they should respond in different kinds of earthquakes. And then finally, here in BC, we already have a portal to disseminate emergency management or emergency situational awareness. And so we kind of have all these pieces already. So the question is, why not combine them? And that's kind of what we're going to present on here today. So we're going to hear about each of those 3 pieces and then kind of our vision for how we could combine them. So here's kind of a sort of technical overview of what that actually looks like. So up here on the top left, you'll see retrieve and reformat shake maps from BC Sims. So that's here in British Columbia, our smart infrastructure management system. We have a network of seismic instruments that our collaborator Yavuz Kaya from the Ministry of Transportation and Infrastructure is going to tell us about how we collect that information about the earthquake and reformat it. And do some interpolating. And then from there, we can take that and put it into the OpenQuake engine, which is a software produced by the Global Earthquake Model Foundation. I think we have John Schneider on the call. So that's an open source, openly available risk modeling tool that we use here at the Geological Survey to run these kind of risk assessments all the time using some Python scripts. And then over here, we can send all those results through some automation workflow to basically make the results instantly queryable to get the information out. And from there, we can send it into GeoBC's Common Operating Picture portal, which we're going to hear about from Gurdeep Singh at GeoBC, as well as Evan Timms, who are going to talk to us about how they're already using information to try to disseminate and communicate about emergencies as they're ongoing in real time. And then our vision is to kind of wrap these things all together in a Jupyter notebook, or just a kind of interactive coding experience that our operational members here in the federal government can put into their workflow, so that basically we're taking tools that already exist, adding just a little extra bit of scripting and a little extra bit of dissemination at the end to, within about an hour, be able to produce some estimates. So what you could expect from this tool once it's operational is that, as I said, within about 60 minutes after a major event, you would have estimates of the critical injuries and entrapments, entrapment being someone who's stuck in a collapsed or partially collapsed building. And right now, what we're suggesting we would share with people is that we'd have that information by the census dissemination area. So that's just a census geometry that roughly corresponds to a postal code size. We could look at the economic impact by municipality. So each city probably needs to know, how serious is this event? Is this, 0.2% of our GDP within our municipality, or is it 20%? We also would like to give some information about the mass care needs. So when we say mass care, we're talking about people who need shelter, food, water, toilets, so people who are going to be displaced from their homes. And we can view that by the municipality or the neighborhood, depending on where the resources are and how we may need to share them in a kind of mutual aid situation. We can look at the hospital demand by neighborhood. So those are people who need more than first aid, but who we expect that if we can get them to a hospital, that we can save lives. And then finally, we can take a look at some of the debris generation. So if we know that there will be major debris generated along some of our main road corridors, then we could give some information maybe to first responders about which routes they may need to avoid. And then kind of the vision of how we see this being implemented. First, it's great for some scientists and engineers to come together and say, this is the tool we think we should build, but it's not really helpful until we know that the community can use it. And so that's why we're so appreciative to have some practitioners and community members here today to give us some feedback, because we want to make sure this is designed with the end user in mind. So today we'll get the feedback to know, is this tool worth making and is it impactful? And then from there, we can start to think about how we would actually go about implementing it within an existing operational mandate. So again, looking to our seismologists, and can we put this into their workflow that they already have a mandate to respond after an earthquake. So our kind of timeline is that we would have a full implementation and external access point for the data by 2021. That maybe by 2022, we can think about how we're going to scale that to a national level in terms of the dissemination, because we have GeoBC here in BC, but we need to look into who are the partners in other provinces. And then finally, we know that in the next few years, we're going to have the Earthquake Early Warning Network that's that's coming up right now. This is kind of a snapshot of the Ocean Networks Canada existing earthquake early warning network, but the federal government is rolling out one as well, working with partners. So we expect that maybe by about 2023, we would be able to use information from that network to generate the shake maps that would go into this methodology. So today we're going to hear some presentations, as I mentioned, about measuring the earthquake from Yavuz, estimating the damage and automating the workflow from myself, Drew, and Yost from Natural Resources. We're going to hear about how to disseminate the results from Gurdeep and Evan. And then we're going to take a look at some sample data that corresponds to that video we watched with a magnitude 6.8 earthquake to see how this might actually look. And then from there, we'll ask for your feedback. So we're going to go into a breakout and get some, you'll have the chance to say, this is not the indicator I care about. Like, I want to know about business interruption instead, or, this isn't how I need it visualized. So hopefully everyone can stay with us until then. And yeah, so from here, I'm going to actually turn it over to Yavuz, who works with the Ministry of Transportation and Infrastructure, to share.
Yeah, thanks, Tiegan. So today, what I want to do is to give you a high-level summary of what BC SIMS program is about. BC SIMS is a province-wide seismic monitoring system designed to help the ministry's post-earthquake response plan. This program has been initiated by the Minister of Transportation with very close cooperation with the University of British Columbia. Our region is very seismically active. What you see on the screen is all the earthquakes that has been registered with the BC SIMS over the last 10 years with magnitudes 1 and above. So this is a very clear indication that our region is very seismically active, and then we should be monitoring all these activities. BC SIMS system has two main components or sub-networks underneath it. Strong ground motion network and the structural health monitoring network. Today, I will be only talking about the strong motion network. So more background about BC SIMS is, so BC SIMS started with a strong ground motion network. Geological Survey of Canada currently maintains acceleration network of 120 strong motion stations across BC. Minister of Transportation has contributed that network with 14 new stations, bringing the total number up to 160. Starting from 1990s, Ministry has also involved in installing those kind of sensors on their infrastructure, together with the strong motion network and the structural health monitoring network that we combined them into one common platform that is British Columbia Smart Infrastructure Monitoring System. So we have approximately 160 stations, earthquake sensors installed across BC. Most of them are localized on the Lower Mainland or the Vancouver Island. We have some sensors installed in Queen Charlotte Island and also all the way up to North Prince Rupert. So basically, this shows the locations of the existing network. Minister of Transportation owns and operates, maintains over 2,500 bridges on highways across BC. These blue dots shows the locations of all those bridges. The green dots are the locations of the schools, private or public. The brown dots are the tunnels that Ministry owns and operates in the British Columbia. So basically, Ministry has a lot of assets that are prone to seismic activities. So once an earthquake is registered by the BC SIMS system, an earthquake notification email is sent out to all the users that has been registered with the platform. So this is an example of that email that you would receive, the magnitude of the event and its location, closest cities to the epicenter, closest earthquake sensors to the epicenter. And if you click on the link in the email, it will automatically take you to the website that will show you or give you more information. If you are not registered with the BC Sims, you can do it so. Go to the bcsims.ca, create a user profile. There are a couple of options for you to choose whether you want to be notified by email with earthquake reports or earthquake notification emails. With ministry's post-earthquake response plan, if we have procedures in place, if a magnitude of an earthquake is above a certain level and if it's close enough, a second email is sent out to ministry employees who will take place on post-earthquake response plan efforts. So we will ask those people to check in their status after the earthquake. This is through an email again. So here's an example. You would be asked to provide your job title, where you're located, whether you are ready to respond to post-earthquake response, and then register it. Once this is all done, then we would know who is available for post-earthquake response. The main idea behind maintaining such a platform in the ministry is to create these shake maps right after an earthquake. So here's an example of one shake map that was produced after an event, a 4.8 earthquake on Sydney Island in 2015. So the green dots here are the earthquake sensors that were triggered by that earthquake. And basically what you do is you bring different layers of infrastructure on top of this shake map that will immediately let you know which part of the city or which part of the region you should pay attention to. Or you can bring a school layer or tunnel layers or whatever layer you want to lay out on top of the shake map. There's a more close-up view of the SkyTrain guideway with respect to shake map and their location with the earthquake sensors. So another product of this platform is an earthquake report. This earthquake report is produced immediately right after the earthquake. So the report will summarize the metadata of the earthquake, will give you a tabulated data of bridges, tunnels, schools, and how many of them are located within certain radius around the epicenter. And it will also give you a list of structures that we have and their expected shake map PGA readings with respect to their earthquake hazard levels. So basically, we are using ground motion prediction equations of Boer and Atkinson 2008 to create these shake maps, and we use VS30 values that were preset for certain locations over a region to calculate amplifications. The sensors are currently calculating PGA, PGV, PGD, and KSI, and 2 spectral accelerations at the location of the sensors, and that's how we interpolate those strong motion data over a region. So it usually takes 3 to 5 minutes to collect all this data from the triggered acceleration sensors, then another 5 minutes to calculate the shake map, additional 1 minute for PDF report generation, and then we will post all this information on the website. So it usually takes 10 to 15 minutes for a shake map to be created automatically by the system and posted on the website. So basically, all this data will be available on our website following an earthquake in the following format. You will have an image file of the shake map, or you can have a digital data of the shake map on MATLAB mat file or CSV file. You will be able to download it from the website, or we can automatically send it to anyone who is interested. So in this data, we will have PGA, PGV, and 2 spectral accelerations over a region. They will be provided by approximately 400 meters grid. So that's basically what I wanted to say. And if you have any questions, I can take it, or we'll switch to the next presenter.
Thank you, Yavuz. The next phase after we've got the earthquake information is that we would, at Natural Resources Canada, begin our process. We can conduct a seismic risk analysis. So I want to talk a little bit about what that entails. Here in the white text going from the bottom up, generally speaking, there are 3 elements that have to be involved to conduct a seismic risk assessment. We need some information of the seismic hazard. So that's the amount of shaking that's actually occurred. So in this case, it would be the BC Sim shake maps from Yavuz. So we can get an estimate of how much shaking with the different intensity types has occurred in which locations. From there, we need to know something about the exposure, which is basically means what's our built environment, our building stock, what's it made out of, what's the construction year, where is it located, on which type of soil. So in this case, we do have a data set that extends across all of Canada that's uniform, where we have some information of kind of representative building types. We also, for the Lower Mainland region, have a site level inventory of every building. It's about 500,000 buildings in total, including their construction year, their construction type, the building material. And all of this is really important in order to understand how it may respond to that shaking that we talked about a second ago. And then finally, we need to know the vulnerability of those buildings to shaking. So the vulnerability or the fragility is basically functions that relate the amount of shaking to an expected level of damage and the probability of reaching that level of damage for the different building typologies and the level of code that they would have been designed to. So in this case, we're using the OpenQuake engine that I mentioned earlier from the global earthquake model. And so they've taken the HAZUS functions, HAZUS being the FEMA, the Federal Emergency Management Agency Administration, down in the US. FEMA produced this software called HAZUS. And so the functions were converted from that to be used in OpenQuake. Once again, though, here in the Lower Mainland, we do have our partners at UBC have been working on updating those fragility functions for our BC specific construction practices. For example, the height of foundations that were normally poured in this area. So rather than taking a kind of North American view of things, we can once again refine even more here in BC. So something we could think about in the future. And then you put all 3 of these together to establish the physical seismic risk. So that's the probability of damage and loss to the people and structures due to an earthquake. And this is something that we're doing regularly here at the Geological Survey of Canada. So we routinely run these scenario risk assessments where we take an earthquake that is credible and perhaps a likely earthquake scenario or a scenario that's useful for planning. And we run it through the OpenQuake engine to look at some of the outputs. So here I'm showing the number of red tagged buildings. So those are buildings which are irreparably damaged and will have to be torn down and which are also uninhabitable immediately following the earthquake. This is for a scenario earthquake in the Gulf Islands, a deep event, so quite similar to the one we're looking at today. And the model estimates not only the damage to the built environment, but also the economic losses and the subsequent impacts to people and businesses. So here on the bottom, I'm showing some of those economic impacts. So it's the total loss for that event. In this case, the one I was looking at was about a $20 billion loss. And we can break that down by what was the construction type that contributes most to the dollar losses or to the damage or to the human fatalities. And generally speaking, a run takes about 4 minutes to conduct with our national level inventory using shake maps that are pre-computed. From there, the results are pushed to GitHub. That takes about 1 minute. So in total, the risk modeling element of this work, we expect to take about 5 minutes once it's implemented. So speaking of implementing or operationalizing, as I kind of alluded to before, it's the Canadian Hazards Information Service, or CHIS, which has the mandate to respond to earthquakes. So they have actually 2 seismologists on call 24 hours a day, one in the east and one in the west. And those are the people who are responsible as soon as an earthquake goes off that's of a certain size. They would, within about 10 or 20 minutes, be able to go in, make sure that the location and magnitude are correct for that earthquake and begin issuing the emails. And so our goal here is that we could implement our workflow, so that risk assessment workflow, into a Jupyter notebook, which is what I'm showing here on the right, kind of a sample. So it's an interface where we would perform the tasks of getting the shake map from BC Sims, preparing the exposure, running the risk model, the damage model and consequences, and then exporting all of those into GitHub. And so the idea is that it would not take too much extra training for the seismologist on call to be able to run this as well. And that we'd be able to produce not only spatial data, which we're going to show you, but also just really rapid totals of who's been impacted. So, within approximately 5 minutes after the shake map is produced, we would be able to say, what's the total economic loss? What are the total number of expected fatalities? What are the total number of people who we expect to be displaced? Which will be helpful just in terms of, municipalities would like to know what's happening specifically in their region, but just for the activation of the different levels of emergency operation centers, we need to know how big is this event? Is it impacting, the lower mainland? Is it impacting the entire province of BC? So we can get that information out quite quickly. And now I'll turn it over to Drew.
Hi, everybody. My name is Drew. I'm with NRCan, and I work kind of doing the nuts and bolts of getting our earthquake risk models from OpenQuake into something that can kind of be disseminated and digested by the wider public. So just going to talk a little bit about these 2 little gears here in Model Factory. And if you're not kind of a technical person, some of this might be a little bit technical, so feel free to let your eyes kind of glaze over for the next couple of minutes. But what we've got here is a system that we've called Model Factory, and we use it routinely, as Tiegan was saying, to transform the earthquake risk scenario outputs that we're calculating on a regular basis. And we do a little bit of data massaging and to bring that into a format that's digestible on the other end. So this is something that we use routinely in our earthquake risk calculations, but we think it's applicable to kind of a real-time scenario. So at its core, what it is a bunch of SQL, Python scripts, all wrapping around a PostGIS spatial database. And in a real-time scenario, what we'd want to do is trigger it automatically with some cloud infrastructure that would be listening to the GitHub repo. So you have your seismologist on call, they calculate the raw OpenQuake outputs, they push it up to a GitHub repo, and that kicks off the process of Model Factory running. So the first step we want to do is a little bit of data validation. So we want to make sure that the model is populated and it's in the right format that we think is in the right format that we can propagate through the rest of the system. We want to ingest the data into the database. We can very quickly generate some Sendai indicator views. And then we package that data up and we put it into an API service. And that's something that can be widely distributed to multiple different systems. One thing that's important to us is we've been developing this entire thing out in the open as we go. So the source code's freely available on GitHub. Anybody can go and take a look at the repository. They could watch as we develop the code and as we go. They could submit issues, anything like that. So once we've got the data packaged in spatial database, it goes up to an API service. And I'll pass it on to Joost to talk a little bit more about the API.
Hi everyone, my name is Joost Van Olden, and I'm also on the tech team working with Drew and Tiegan and Murray on some of the technical underpinnings of a lot of the work that we're doing with the Open Disaster Risk Reduction Platform. So it's a pleasure actually to present some of our work with this type of audience, I have to say. So as Drew had mentioned, we are sort of repurposing some existing infrastructure that we have to support internal business. And I think with some small changes, we're pretty much confident that we could try and move to something that could theoretically be operationalized. So after Drew's model factory piece does all of its work, what happens is that the data gets pushed to an application programming interface, or for developers quite familiar with the concept of an API. And so this API, really the intention is to allow developers access to near real-time data using best practices. So we've got a number of international and national standards that we need to comply with when we provide web services to the public. So we will comply with those. We're building this all to the extent possible with sort of cloud native infrastructure pieces. So the intent there is just to make an architecture that's highly scalable and can meet, as of yet unknown demand. So we are architecting it at the outset, something that can be very flexible in terms of the volume of information that's actually requested from it. So to that, we'll be leveraging some caching and some other neat technologies within the cloud and other portions of the infrastructure to try and reduce the latency for access to the information. We'll also look at optimizing the queries and then the data that supports those queries in the spatial database, such that there's a limited amount of impact on the underlying infrastructure. And we'll be providing the data as Sendai indicators, which I think most people here probably know about. Next slide, Tiegan. So the intention is to really focus on making this super easy for developers. So I do actually have experience supporting first responders in an emergency situation many years ago. And some of the problems that we had was the APIs that we were using were not well documented. So we intend on providing an open API document, which is up on the upper right-hand side. So that's an interactive environment where developers can test their queries and build queries to support their specific requirements. The other thing we're going to do is we're going to provide the data as packages, so geo packages and GeoJSON files through our GitHub repository. So after the model factory does its thing and everything goes to the API, we're going to run another process. So we'll take those data sets and package them up neatly and make it really easy for developers to access. So, one of those formats, GeoJSON, that will be you can serve that file out directly through our GitHub repository, which is really great for developers in the field, and especially for those that are going into disconnected environments. They can have files locally on their mobile device or their laptop and still be able to access the information. So we'll obviously be asking for a lot of feedback and input as we move through this, but we're hoping that we can gather some of that today.
Awesome. Kind of the vision here is that we sort of see it as a baton where it starts with the shake map being produced by Yavuz, and then that baton gets handed over to Natural Resources Canada, where we can do the risk assessment and the automation, and then that baton gets passed over to Gurdeep and Evan. So yeah, take it away, Gurdeep.
Yes, good morning, everyone. Thanks for having us present today. Thanks for the introductions, Tiegan, and all the presenters that laid the foundation for what we're going to talk about today. So I'm here today to give us a little bit of an overview of the Common Operating Picture portal that we have developed in BC. And I'm also joined by Evan Timms, part of my team. He's going to do actually a demo after an overview that I'll be providing. So I'll start off with a question. What was the motivation and driver for this work that we have done? I think the motivation is purely to develop a solution for a common understanding of hazards, risks, situational awareness for stakeholders so that they can develop action plans to respond to hazards, both at local, regional, and provincial scale. So I'd like to share this picture. I've shown that at many presentations before, so some of you may be familiar with that. This is a picture in an agency or stakeholder briefing, which was happening in 2018 during the flood season at the Southwest Emergency Operations Center in Surrey. I think it's a great picture as it illustrates our collective needs for a common understanding of hazards. Now, in context of the workshop today, let us look at some of the business questions which these stakeholders typically would have for an earthquake event. A couple of questions come to mind. What are the likely impacts of earthquake scenario on people and infrastructure? What's the extent of damage and fatalities, and where will these be concentrated? How do we quickly get help to the people impacted and keep first responders safe? Do we have good regional understanding about the impacts? How will various jurisdictions, municipalities, First Nations, other levels of government will collaborate on this issue across the region? And lastly, what actions do we need to take individually and collectively as part of our organizations? And when do we need to take those actions? And I think you would all agree that maps and GIS solutions can answer all of these questions and many more. So in terms of solution, so what's the provincial approach to answer these questions related to the business needs of the various stakeholders? So our approach has been to create one place or platform to access all mapping information to support situational awareness needs for provincial agencies, but also external stakeholders. The COP or Common Operating Picture portal is envisioned to be a one-stop shop, and it includes various self-serve tools to provide a number of services to meet needs of a wide range of stakeholders for multiple hazards, whether it is flooding, fires, landslides, earthquakes, so on and so forth. First and foremost, it includes curated data that already exists, and there are a few examples here on this slide. And the idea here is to take the data and add some value by providing some context and interpretation on how to use it, not only at a provincial scale, but also at a local and regional scale. We also have included several tools that could help analyze some of the data to answer specific questions. For example, when it comes to flooding, what the water level, if the water level was to rise to a certain point during flooding, how many number of buildings would be damaged, and what would be the estimated costs, economic loss and costs within a community. Users are able to develop planning scenarios to better understand the impacts of hazards, and this could inform development of mitigation plans. We have also developed various mobile apps that enable real-time data collection and integration into the Common Operating Picture portal. A great example is the damage assessment work that we did with BC Housing to assess damages to buildings post an earthquake damage assessments. But also more importantly, recently we're working with Ministry of Transportation to look at the impact of a potential earthquake on the bridges, which the Ministry of Transportation that you see earlier in the presentation from Yavuz. Recently, we have also deployed a drone technology for flooding in Williams Lake to support damage assessment and recovery activities. All this information flows into this one Common Operating Picture platform. Now, what's our vision for this Common Operating Picture platform? In the previous slide, I showed you some examples of curated data, story maps, and tools. There are a number of other areas that are part of the future vision and are grayed out on this slide. It's expected that the province will explore some of these areas in near future as part of the modernization of the Emergency Program Act, as well as the BC Climate Change Adaptation Strategy. We have leveraged this platform of the various past few years to collaborate with various stakeholders to first identify hazards, the potential impacts, and share information within various teams across the province. Now, when it comes to emergency management, we need to take an all society approach as stakeholders have data, knowledge, and expertise to contribute. This is also one of the guiding principles of modernization of emergency management in BC. And we heard earlier today about the Sendai framework. And now let's look at how are we adopting the principles of the Sendai framework. Firstly, we have implemented the principle by providing access to the Common Operating Picture portal to all levels of government and other stakeholders in BC. That includes First Nations, local governments, CI owners, and federal departments. Secondly, I think the sharing of portal and ongoing training and support that we provide to all stakeholders has provided us a mechanism for ongoing engagement and also collaboration with the stakeholders. Because each stakeholder has data, knowledge, and expertise, and that helps us develop some standards and best practices as we move forward collectively. Lastly, I'd like to also mention we are currently working on a regional collaboration model in Southeast BC to enable integration of data and information at local and regional level into the Common Operating Picture portal. And I believe the lessons learned from this regional collaboration model could be also used to extend this approach to other parts of the province. As part of the workshop today, you will also have the opportunity to explore the portal. And Evan is actually going to provide you an overview today. And I think it's a great platform and a mechanism, as you will see and experience, how we can integrate and share information related to hazards and emergency management across the province. With that, I'll hand it over to Evan, who is going to walk you through the portal and provide an overview of the thematic maps and other products that we have created based on the data that was provided to us by NRCan.
Good morning to everyone, and thanks for having me here today. I think it's great to be able to chat about opportunities we have to collaborate with stakeholders across the province, and how the Rapid Disaster Modeling Workshop can help ease some of those questions surrounding situational awareness after an earthquake. So I'm going to be giving a short talk on how I created this platform in our Common Operating Picture and the data that feeds into each of these pieces. Using ArcGIS Online eases some of the hurdles that present themselves in emergency situations, like this, where maps and data need to be shared to multiple different stakeholders. Common maps need to be created for people to view many of the same pieces of data in order to make informed decisions. Putting data into the Common Operating Picture for a scenario like this allows for a map of any area to be created. We can scale and zoom around, and one of the best benefits of having something like this is that you can view the scenario information as well as near real-time data feeds getting updated frequently, whether that's emergency social service locations, river levels, or traffic congestion, for example. So once I received the model's scenario data from NRCan and the Ministry of Transportation, I started to ask myself and others, what is this data really supposed to show? What would someone looking at the data at face value be able to see? So first is the shake map, which is a sample scenario to which you will receive from the Ministry of Transportation and NRCan. And this really paints a high-level snapshot of where the most high impact peak ground accelerations occur. And this is expressed in fractions of gravitational acceleration. It ranges from 0.03 to 0.2 in the 6.8 magnitude earthquake. And once you move to the next tab, this is where you start to see some of the thematic data and accompanying situational awareness data. And this is critical for emergency managers to make informed decisions on everything from where to allocate resources, funding, or staff, right down to rerouting traffic if need be. So the first data layer that's turned on is showing the distribution of critical and non-critical injuries. And right away, you can start making some connections just looking at the distribution of the data across the Metro Vancouver area. The critical injuries data is showing at the neighborhood level or census dissemination area unit, and gives a representation of how many people would be injured or trapped if this were to happen. So I'm going to turn on the road blocking debris as well. And now couple this with the critical injuries and entrapments layer. And what you'll see is that the amount of debris which may impact traffic and first responders. Now, if we turn on hospital demand, you can kind of use the hospital demand and road blocking debris layers to understand how many people are going to be in need of hospital following the event, and how much debris in tons would be generated by such an event. So then hotspot areas can be focused on at this point, given the impacts on site-specific resources, which can be identified, and local governments can start working together in order to mitigate some of these. For example, in Delta, it looks like there will be a significant risk for critical injuries and entrapments. There's going to be a high demand for medical services, and nearly 100,000 tons of debris generated. So we can start using the true power of the web apps in this situation, as stakeholders may want to know where emergency facilities are, like first responders, urgent and primary care centers, as well as hospitals. The earthquake may have triggered a problem with some of our radio towers. So getting critical messaging out to the public may pose a problem. So what other tower providers are in the area? which we could start using to communicate those messages. So it's these types of questions that we can start to answer using situational based data in conjunction to the modeled scenario data that has been generated. And the same goes for our mass care needs data layer, as it provides a better understanding of the number of people that are expected to have damage to their homes. And this data is aggregated to both the neighborhood level and to the municipality level. So here's the neighborhood level, and then here's the more general municipality-driven data layer. So I've also included critical infrastructure data, which is available, the surrounding topographic features and administrative boundaries, as well as the modeled earthquake hazard data. Just for an example, there's also a data screening tool in the corner of the left side of the map that allows the user to do an analysis of the data that's in a particular area. So let's say I'm interested in a particular area near the airport here in Vancouver, in Richmond. I can use this data screening tool and draw a polygon. But first, I'm going to turn on the population data that we have, which kind of gives you a breakdown of how dense the locations are here. And I can select an area. I'll just select right here. And I can click the report button, and this will give me a breakdown of how many people are in the area that may be affected. It will give me a breakdown of hospitals, first responders, etc. And I can export those out into a PDF and print them off. And these are just some of the tools that are available in this scenario. If there are other tools that you may think be of benefit, I'd be happy to chat with you further. So having situational awareness on a tool like this is critical for fast response times and really leverages the ability to update information in near real time and then provide it back to stakeholders and emergency management staff to make those decisions. I appreciate you having me on here this morning, and I'll look forward to the discussions that follow out of our presentation.
Thanks, Evan. And yeah, thanks to all of our presenters. So at this point, we're going to move into our breakout. So we're talking today, we wanted to give you guys an example of kind of what things look like. So using this example, deep 6.8 earthquake, interslab scenario that is the same location as the 2015 magnitude 4.7 event just off of Sydney on the Sanish Peninsula. But we've scaled it up to a 6.8, which is more like the 2001 Nisqually earthquake. So I do want to give the option. We're going to go into breakout rooms. If there are people, I know we have some folks joining us from Italy where it might be quite late. So if you can't stay for the breakout, there's a Google form and I'll paste that into the chat. We do really encourage everyone who's on the line to stay for the breakout because we're going to ask some targeted questions about this visualization. Your facilitator will have the opportunity to help you do, kind of a continued tour through the tool that Evan just showed us. We're going to split off into breakout groups and we're going to have 40 minutes for discussion. We asked everyone to put a letter corresponding to which breakout group you'd like to be assigned to. I believe that Daryl's going to set it up, so you'll have the option to pick which one you want to go to, but just in case, if you haven't updated your software, we can put you in the right one. I do want to invite, however, if there's anyone, I see we have a lot of others here today. So if there's anyone, if you're an other and you want to join in on a different breakout group, just because you think it would be interesting, you're welcome to do it. Or if you haven't assigned yourself yet, don't feel pressured. But if you do have a primary response role that is one of those breakout groups, we'd ask you to go to that one so we can have kind of a focused discussion. And I think that's all for me. We'll meet back here in 40 minutes. You can help us out, Daryl. Thank you.
Feel free to unmute yourself and just jump in. And if you don't mind, just introduce yourself first if you're going to speak, and just who you are, who you represent, and share your thoughts and suggestions.
I'll chime in. Thanks, Murray. This is great. I really, it's quite impressive what everyone's doing, and everything's going in the right direction from what I can tell. I'm Dave Wald. I'm at the USGS and National Earthquake Information Center, and I've been running a lot of these real-time earthquake information systems like ShakeMap and Pager and DigiFeel and stuff like that. I guess my concern here is, you know, John and I have done this modeling different places around the world, and I guess I'm concerned that is an impression that this modeling is accurate and that you can take this down to an urban city block level or census tract level, even if you have a good shake map and doing the loss calculations with OpenQuake and hazards fragilities. There's a lot of uncertainty involved in loss modeling. We really want to keep aggregating it to the point where its uncertainty is kind of commensurate with, you know, the modeling expectations. And the biggest challenge in Canada is that there's so few earthquakes to validate the modeling that it's not so clear how far to take that. You know, it's nice to have scenarios and you see what ifs, but the real earthquakes that would inform that decision of how far to take that are few and far between.
Firstly, I'm really impressed by what you've been able to put together, just being able to coordinate across agencies and to pull all the information together into a coherent picture of what's possible, I think is a great achievement. And I think what Dave's referring to is now, okay, practically, how does that actually work? And I agree that it is potentially a minefield if you start putting out information that's either too precise but not accurate, or perhaps too coarse when people expect something more, higher fidelity. But I guess you might want to think about how you parse that information to different users, you might say. So the emergency management system, you might want to give them all the detail that's possible, but recognizing that there is a lot of uncertainty in the process, and while what you disseminate to the public is perhaps made much fuzzier. I think the information on, for instance, to the public, you might want to give information on what you see as being the most vulnerable structures.
I may just chip in. It's Jack Wool here. I come from a company called Connecticut Risk, and we are basically practitioners of using some of the building-specific technology to help individual owners, or so we would say the public, and sort of manage their earthquake risk. And I actually see great value in sort of the larger regional assessment that's being put forth here. I think one of the obstacles sometimes when we're dealing with individual owners who are making decisions about their own portfolio of assets and whatnot, they want to know specific things that they could do and what the business impact or the value proposition is. And in that, I don't think that maybe the regional assessment is really being able to offer that kind of information. But what it is really helpful in kind of my experience is that sometimes people are looking for more strategic sort of decisions, not relating to whether you need to upgrade your infrastructure or buildings, but whether or not you can actually get people to work in a particular location. And I think that's one aspect of risk management for the individual property owners that is really relevant. And I think that's what this tool can provide.
I like aggregate stuff because it gives you a really good idea of what's going on, but I also like to know the actual details. And I know with maps and the way we can put layers on maps these days, I don't see why we kind of can't have all three. How you go on to Google Maps, so you can see, I want to see satellite, I want to see my road map, I want to see, whatever the other option is. In that 16 to 18 hour time frame, there's quite a lot of information that comes in. The other point I wanted to mention is that even during the Nisqually earthquake, which would be, social media was not anywhere near what it is today. we were overwhelmed. You know, my phone in my office didn't stop ringing for 2 hours. Someone, thank God, came in and sat and started answering my phone for me so I could deal with locating the darn earthquake. But, you know, and then getting all of our information and doing media interviews. I mean, the phone lines were overwhelmed. Our web server slowed down. We couldn't even access the server to put up data because it was being hit so hard.
It'd be nice to have some of these downstream decision-making tools and information platforms to be cross-border consistent, you know, and ultimately not have to explain things differently depending on which side you're on the border.
You know, the focus today has been on BC, and that is where we kind of have the richest data sets, and obviously a lot of the risk too. But ultimately, we'd like to do this for the entire country. And I think kind of based on like Murray and Tiegan's research over the last few years, and of course, through our partnership with GEM, we're well positioned to do that scaling and would love to work with you absolutely as well. And I mean, there's so many benefits to having a single platform. And so, I mean, from just basic risk communication to decision makers to robustness of systems, absolutely would love to take that opportunity and take you up on that and make this kind of multinational piece. So thank you.
On behalf of you know, Tiegan and the team presenting here today, I just wanted to take this opportunity to thank all of you for the active conversation, the active discussion, and for sharing your thoughts and insights. I think we've got some, you know, very tangible input here. Dave, your comments about scale of aggregation are heard, and we'll certainly be thinking about that. You know, this idea about partitioning our messaging is really important. And anyway, so thank you so much. We really appreciate it. And I think we're going back to.
We just have a few minutes left. And I think with 6 groups of us, we won't have time to go through and hear some of the feedback, but I just wanted to take this opportunity to thank everyone for coming. Thank you all for staying for the breakout, for giving your feedback, for discussing this more. I know in our group, and I'm sure in lots of others, we had really a two-way exchange of information of, you know, getting questions from people in the group, you know, giving questions to them. And it seems like really a rich area for us to keep working on things. Maybe I'll selfishly end with a comment that I heard in the breakout group that I was just in, that a lot of our systems for these kinds of events are quite untested because we haven't experienced a major earthquake in this region in such a long time. And particularly given the pandemic, this was Ginger Sherlock's comment, so I'm going to give her attribution because I thought it was quite insightful. Keith mentioned that with the pandemic, we're having to work in virtual EOCs, which means that our GIS is even more critical than it ever could have been before, because perhaps before you would have had a whiteboard or a flip chart or a map with literal pins in it. And now we have to be online. And so Keith made that comment, and Ginger made the comment that our GIS folks may think of themselves as the data people behind the scenes, but in the event of a major earthquake, we need them to be our first responders as well, and people who are on the fly, you know, in the first few hours, helping us to visualize the impact so that we can make best use of our resources and communicate what we need to the province or to other municipalities. So yeah, I thank all of you guys for putting on your first responder hats today to think about how should we do this. Yeah.
First and foremost, thanks to Tiegan and all of the collaborators for bringing your contributions to the table here for discussion. I think this is, you know, the kind of forum that we're looking for to get your feedback, to help direct our thinking about where things might go in the future. So we really want to thank you for taking the time. In lieu of speaker gifts, which we normally would do if we were in a seminar session, we would be offering gifts to our speakers. And in lieu of that, given the circumstances, we're offering a $400 donation to preparing our home. It's a community-based organization that provides support to Indigenous youth to build their capacity to be leaders in their communities in emergency preparedness. And so this is a great effort that we're very pleased as the URBC community to be able to support in even a small way. But an example of kind of both, I think what you're seeing through the symposium is the blending of bottom-up and top-down initiatives around disaster risk reduction and adaptation planning. And this forum is really where those streams come together.